Hello, students. Welcome to the VAIR community. The set we have for you today is from CAT 2020. This is from the third slot, and it is a comfortably easy set, except for the last question that came in along with the set. So without wasting any time, let's dive into the set immediately. For all of you who are new here, this is the VAIR community. And what we do is we have one particular CAT set from the previous year's papers, the LRDI section mainly, and we discuss one set every single week. So if you want to keep yourself updated with the different sets that have come in the past few years, make sure to like this, subscribe, and share it with your friends as well so that all of you are collectively studying for the upcoming CAT exam as well. All right, let's get right into the set and read the information that is given to us, and also take a look at all the questions that followed the set, just to have an understanding of what kind of a set it is meant to be. Here's the information from the set. So we have 16 patients in a hospital must undergo a blood test for a disease. Now, mind you, this had come in 2020, so it was during the time of COVID. So clearly that theme has been carried forward in the exam as well. It is known that exactly one of them has the disease. The hospital has only 8 testing kits and has decided to pool blood samples of patients into 8 vials for the tests. The patients are numbered 1 through 16, so we have 16 patients, and the vials are labeled as A, B, C, D, E, F, G, and H. So these are all the vials. The following table shows the vials into which each patient's blood sample is distributed. So they have distributed 16 blood samples into 8 testing kits, which are the 8 vials, A, B, C, D, E, F, G, and H. So patient 1's blood basically has been taken and given in B, D, F, and H. Patient number 2's blood has been given in the vials B, D, F, and G, and so on and so forth. So the blood samples of each and every patient has been distributed in 4 vials across the 8 as such. Now let's understand how the vials work. If a patient has the disease, then each vial containing his or her blood sample will test positive. So for example, let's try and understand this information. I am considering patient 5 to be a positive person. So patient 5 is that patient, that one patient who has the disease. So if patient 5 is basically the positive person, then each vial containing his or her blood sample will test positive. That means B will be positive, C will be positive, F will be positive, and H will also be positive. Which means if I take a look at the vials that are spread across, everyone who has B will also show up as positive for that particular vial. It does not mean that just because patient 1's vial B is positive, that patient 1 is also positive. You need to make sure that all of the vials containing the blood should be positive. So I know for a fact that B is positive. I also know that C is positive. That means C for 6, 7, 8 is also positive. Of course, I will have C and B across these as well. Wherever there is a B, it will be positive. Wherever there is a C also, it will be positive. So this is the idea. Then whoever has an F vial will also be shown as positive for that particular vial, not for the disease. So F are positives and H is also positive. So I have H positive as well. Why we are filling this up is to understand the language that is given in the information. So these all vials are basically tested positive. I know that patient number 5 is positive, just as an example. So now what this means is if patient 1's tests are seen, B is positive, F is positive, and H is positive, but D is not positive. Not all vials are positive, which means patient 1 is not tested as positive, because all the 4 of them should be positive for the patient to actually be positive for the disease. That is what the first line basically says. So if a patient has the disease, each vial containing his or her blood sample will test positive. And if you take a look at the table right now, we know that there's only one patient who has all the 4 positive vials. Everybody else has either 1 or 2 or 3 or none of them positive, right? So patient 5 is our basic patient who has the disease as such, just as an example. This is the meaning of the first line here. Now, going back to the next line. If a vial tests positive, one of the patients whose blood samples were mixed in the vial has the disease. Let's trace ourselves back a little bit. So I'm considering if a vial is tested positive. So let's suppose that A is tested positive. That means the vial A has these people's blood in it. So any one of these patients could be the positive patient because A is tested positive, which clearly means 1 to 8, nobody has an A. That means 1 to 8 are free of the disease. They definitely don't have the disease. Also, if you notice, if A is given as one of the vials, you cannot have a B beside it. B belongs to the other set of people. Similarly, if there is a C, you cannot have a D in it. D is given to the other rest of the patients. And likewise, if there is an E, you cannot have an F. There is nobody who has E and F as a combination, or nobody who has A and B as a combination. So they have clearly distributed their blood samples accordingly. So if your blood sample goes to A, your blood sample cannot go to B. If your blood sample goes to C, your blood sample cannot go to D, and vice versa. If it goes to E, it cannot go to F, and if it goes to G, it cannot go to H. That's the basic idea behind the set. So it's either or, either or, either or, either or of these 8 blood samples or of these 8 vials as such. Let's go to the next statement. If a vial tests negative, then none of the patients whose blood samples were mixed in the vial has the disease. So just like we checked for A to be positive, on the other hand, I'm considering B to be negative because your blood sample has to choose from one, either go to A or to B. So if people's blood samples has gone to B and B is not positive, that means none of these patients will be positive. Because everybody who has B will be negative because you need all the 4 to be positive in order for you to be the actual patient with the disease, right? So this is all the information that is given to us. There's nothing else to be done as such, just about understanding what all this information is. And then there are questions directly that follow. Let's take a look at the questions one by one. Question number 1 says, suppose vial C tests positive and A, E, and H test negative, which patient has the disease? Is it patient 14, 2, 6, or 8? Let's try and understand this. Vial C tests positive, so everyone who has C could be the potential patients. So C is positive. However, A, E, and H are negative. So everybody with A, E, and H will not be a patient. Now, out of these, I'm only going to concentrate on these because C is positive here. If they have A or E or H, they are not going to be a patient. So A or E or H, this one has both. 8 has E, so cannot be a patient. 13 has H, cannot be a patient. 14 has A, cannot be a patient, or 15 has A, and 16 also has A. These are not the patients. Your patients are going to be from here, out of which only patient number 6 is left to be a possible patient. So the answer to this one will be patient 6, because everybody else is ruled out because of the negative tests that have been coming through. I hope this entire set is clear. So we have to take a look at every single case over here. And then depending on the questions, we'll have to answer the questions. Each of the questions will have a supposition or they have a condition that is taken forward. Like, for example, question 2 also suppose vial A, etc. Question 3, which of the test combinations is not possible? And question 4 is suppose again. So there are multiple assumptions in the questions, and those have to be considered to answer that particular question itself. Remember to not carry information from one question to another question, because whatever is given in that particular question is specific only to answer that question itself. So suppose vial C tests positive, you cannot consider this situation and answer the second question. It is only for the first question. Once you get the answer to the first question, you're supposed to forget the information given here. And then you go ahead and check the new information that is given in the second question for us. Let's take a look at question 2 now. Suppose vial A tests positive. So clearly, if vial A tests positive, we are looking at all patients from 9 through 16. And if A is positive, we know that B cannot be positive because it has to go complementary. So there's nothing that has A and B together. That means our patients could be one among 9 to 16. And whilst D and G are negative, similar to the previous question, let's cross out everyone who has a D or a G in their code as such. So 9 is out because they have a D. 10 has both, so that's also crossed out. 11 has D and 12 also has D. So these are out. Now from the rest of them, D and G. So I need a G. These have C, so they cannot have a D clearly. Let's look at G's and cancel out the G's. So G is gone here, G is gone here. Now, which of the following vials should we test next to identify the patient with the disease? Now, let's write down the patients that are remaining and their vials as well. So I have patient number 13 who has the vials A, C, F, and H. And I have the patient 15 who has A, C, E, and H. Out of which we already know that A is tested positive, so need not worry about that. That is not even in the options. If I go ahead and test C, will I be able to understand who is the patient? No, because if C comes out to be positive, both of them are equivalent possibility cases for that particular disease. So C is not the best choice because both of their blood is there in vial C. If it tests positive, you will still be confused about whether it is patient 13 or patient 15. So C is not going to be the best choice to go by. The similar thing is for H as well. H is also there in both of them. So if H turns out to be positive, it could again be either patient 13 or it could be patient 15. So H is also not the best bet. What would you do? You would either check F. If F turns out to be positive, then patient number 13 is going to be your patient. Otherwise, if E turns out to be positive, you will definitely know that patient 15 is the actual patient. So I'm only going to check for either F or E, out of which vial E is there in my options. So I will mark vial E and I will go ahead. This set is completely question specific. There was no initial work to be done as such. It was just about understanding how this works and then looking at each and every question because there is additional information given in the question. Let's go to the next question. Which of the following combinations of test results is not possible? Is their actual decision? So can I have A and G positive, D and E negative? Now, if you remember the breakdown of the vials, we know that everybody whose blood sample has gone to A, the same blood sample cannot go to B. Likewise for C and D, likewise for E and F, and likewise for G and H. So I cannot have both of them negative. If I have A and B both negative, for example, then everyone is ruled out because 9 to 16's blood is in A and 1 to 8's blood is in B. If I eliminate A and B both, if both of them are negative, then there is no patient who has a disease. But according to my initial information, we know that there is exactly one patient who has the disease. So I cannot say that A and B both can be negative at the same time. Let's see if this helps us out. D and E, can D and E be negative? Yes, they can be negative. Can B and D be positive at the same time? Yes, they can. Can A and G be positive at the same time? Yes, they can. While B positive and C, F, and H negative. This is also fine. Whilst A and E positive and C and D negative. Now, this is something I can't have. If C and D are negative, 1 to 4 has D, so they are out. 5 to 8 has C, so they are also out. 9 to 12 have D, they are out. And these have C, they are also out. That means all my patients are tested negative and I cannot have somebody with the disease. That's why D is going to be an answer. I cannot have C and D both negative together. This also can be done by observation of the table itself. Let's look at the last set of the question. Let's look at the last question of the set. That is question number 4. Suppose one of the lab assistants accidentally mixed two patients' blood samples before they were distributed into the vials. Which of the following correctly represents the set of all possible numbers of positive test results out of the 8 vials? So your options start with 4, 5, 5, 6, 7, 8, 4, 5, 6, 7, 8, and 4, 5, 6, 7. We have to understand that the mixing of the blood tests, the samples, happened before they were sent into the vials. We'll have to take certain conditions or certain examples and try this one out. For 4 vials to be positive, what could be a situation? So everyone has 4 vials, basically. Let me take an example where we are mixing. Suppose 1 and 2's blood samples were mixed. And there was a third person, let's say the third person was positive. So if patient number 3 was positive, that means B, D, E, and H are positive. All right, I know that patient number 1 and 2's blood samples were mixed, but does that affect anything else? No, because they are both negative, right? Only patient number 3 is positive. So B, D, E, and H will be positive. That means I can have 4 of them as positive. The minimum can be a total of 4 because it starts from 4 onwards. So if 1 and 2 are mixed, I know that B and D will show up positive, even H will show up positive, but F and G will not show up positive. That is why these will not be shown up as positive or actual patients. Only patient number 3 is the one with the disease. So I can have 4 as an answer. That means option B can be eliminated because it does not have a 4. This is the least case condition where there are 4 positive test results or 4 vials, basically. What can be another situation which can give me the other values as well? If I take 1 and 2 itself, let me erase this. If I take patients 1 and 2 and one of them itself is positive, so let's say patient number 2 is positive, then what would happen? If they are mixed up, I would have B, D, F, G, and H. All 5 of them shown up as positive because patient number 2 is positive and they have mixed the blood. So there can be 5 of them also that are shown as positive test results. So I have 4, I have 5 as well. Now 5 is there in all of them. What is not there is, let's say I need to see for 6, 7, or 8. 8 is there in only one of them. Let's try and combine certain patients in a way that we will get 8 positive results, or whether we can get or not. For 8 positive results, we know that we have to take something which is completely not a part of one of the patients and is a part of the other patient. For example, I need to take vials which are completely different from each other. So I can consider patient number 1 and patient number 16's vials to be mixed because nothing is in common between the two. Now, if patient 1 and 16's vials are mixed, how many of them will show up as positive? A will show up as positive, B will show up as positive, C, D will show up as positive, E, F will show up as positive, and G, H will show up as positive. Because they were mixed, and I'm considering one of them is positive. So because they were mixed, everything will show up as positive. That means I can have a total of 8 vials, all of them showing up as positive. Now, because this happens, we are looking at option number C, which has a minimum of 4 and it also has a maximum of 8. Therefore, my answer will be C and not A, B, and D. So this was again a little bit of an elimination approach, which we used to answer question number 4. This was one of the trickier questions of the set. The rest 3 could be comfortably done. So even if you are thinking of not taking up the set because question number 4 is difficult, it doesn't mean that if you pick a set, you're supposed to answer all the questions of the set. The moment you answer the easier questions and go ahead to the next set, that also is more than sufficient. So it's all right if this gets a little confusing. Instead of getting a negative mark, if you're not able to understand how to get to these, if you leave question number 4 and do the first 3 questions and move on to another set, that is also fair enough as an attempt in the LRDI section. So here we come to an end of this particular set, and stay tuned to our channel for more such sets coming up every single week. Thank you, and I'll see you in the next video.